Okay, let us understand a very important theorem in triangles, which is basic proportionality theorem. We, in short form, we call it as BPT. Okay. Now the theorem says that if a line which is parallel to a side, one line we are drawing which is parallel to any side. See, just example, this L is my line which is parallel to BC. Okay, it intersects the remaining sides. It intersects the other two sides, which is AB and AC, at 2 points P and Q. Then the line, this L, divides the two sides AB and AC in equal proportion. Okay, what is the meaning of this last statement? That it divides the sides in the same proportion means, it means that the ratio of this AP and PB, ratio of this upon this is equal to ratio of this and this. Correct? First, understand the theorem that it says if a line which we draw parallel to any side of the triangle, in this triangle I have drawn the line parallel to BC, and if it intersects the other two sides in 2 points P and Q, then the ratio AP upon PB is equal to AQ upon QC. Right? This is very important theorem of triangle BPT. Okay, and now we will prove it how this ratio is equal. Okay, let us prove the BPT. I have drawn this triangle ABC and my line L is there, which is parallel to BC, intersecting at P and Q. What extra I have done? I have just joined BQ and PC. Okay, now let us say ratio of area of triangle APQ upon area of triangle BPQ. Okay, so what is the ratio? Ratio of area APQ and BPQ. It will be what? This triangle APQ and BPQ. Again, we can write half base into height. It will be like half B1 into H1, half B2 into H2. This half will be cancelled. Okay, now see, if I draw a line perpendicular to this from Q, this QM is height of APQ also, if I take base as AP, and this QM is height of PB also, if I take PB as a base, because this is same perpendicular, right? So we can say that the height of these two triangles are same, so we can just cancel it. Okay, and we will get base B1 is what? AP, and base 2 is, understood this thing? What I have done? I have drawn a perpendicular QM which is perpendicular to AP also and is perpendicular to PB also, because it is same line. Okay, so perpendicular from a point to a line is same wherever you take. So the height is same for these two triangles, APQ and BPQ. So the ratio of area will be what? Ratio of only bases, AP upon PB. Now similarly, we can write area of triangle APQ upon area of triangle CPQ. Here also. Okay, now this time I am taking base AQ, so I am drawing perpendicular this, let us say PN. Okay, so here also this PN is what? Perpendicular to AQ, and PN is perpendicular to QC. So I am directly writing ratio only bases. So AQ upon QC. I'm only taking bases because my height is same. Clear? Now take these two triangles, triangle BPQ and triangle CPQ. I'm taking triangle BPQ and triangle CPQ, right? It was given that this line is what, parallel to BC. So if I take this PQ as my common base, this base is common to both triangles, triangle BPQ and CPQ, okay? And if I draw height will be what, from this point and perpendicular to this line. This is my height for this triangle. Similarly for CPQ, my height will be this. Let us say BR and CS, okay? But these two lines are parallel, so we can say that BR is equal to what, CS. So if I say this triangle, area of this triangle BPQ is what, half PQ, I am taking base, is equal to, and height is BR. Similarly for this triangle, it is half PQ into CS. Now we are saying that BR is equal to CS. It means what? Area of these two triangles are equal, half of equal, PQ same, and we are saying BR is equal to what? CS. So we can say that area of triangle BPQ is equal to area of triangle CPQ. Now look here, BPQ, CPQ, numerator APQ, APQ. So we can say that these two ratios are same, hence these two ratios should also be same. So AP upon PB is equal to AQ upon QC, right? You need to write whenever a proof comes, that proof BPT, then you need to write stepwise. First statement of theorem, then if you want to do any construction or given, if whatever given in the theorem, you need to write that. Then if you have any construction, do the construction and then proof. Correct? Right. Now if the converse of this PPT, what is this? That if in any triangle ABC, suppose there is a line L and it is not said whether it is parallel or not, but if it cuts again P and Q, and it is given that AP upon PB is equal to AQ upon PC, if it is given, then it means that this line is parallel to BC. This is known as my converse of BPT. Okay. In this video, we are going to learn about some other theorems which are based on basic proportionality theorems. Okay. The first one is angle bisector. Okay. Now this theorem says that the bisector of an angle of a triangle. Okay. There is a triangle ABC and we have drawn line AD which is bisecting angle A. Okay. So this AD is what? The bisector of angle BAC. So the bisector of angle of triangle divides the side opposite to angle in the ratio of a remaining side. What is the meaning of that? That this ratio BD upon DC. Okay, this angle bisector is dividing this side BC into BD and DC. So this statement can be written in the form of BD upon DC in the ratio of remaining sides, means this should be equal to BA upon AC. So this BD upon DC is equal to what? BA upon AC. Remember this, that if you are taking BD as first, you need to take BA. DC, CA means same side. BD, then the side common to this point B, and DC, then CA. So BD by DC should be equal to BA by AC. Okay, now we will prove it. Now let us prove this angle bisector theorem using BPT and some other properties of triangles. I have drawn the same triangle, this ABC, and AD is what? Angle bisector, and we need to prove BD upon DC is equal to BA upon AC. What I have done, I have drawn CP parallel to AD. So construction, you can write CP parallel to AD, right? And I have extended this BA to join this. So I have made this triangle BCP, bigger triangle, where this PC is parallel to AD. And we have just learned in BPT that if a line parallel to any third side, okay, it divides the other two sides in the same ratio. So by BPT we can write BD upon DC, this upon this should be equal to what? This upon this. BA upon AP. Is it clear? What is this? In this triangle, look at this triangle BPC. This AD is parallel to BC. In BPT, what we have done? If this is parallel to this, this upon this is equal to this upon this. Similarly, so if AD is parallel to CP, this upon this is equal to this upon this. Same thing I have written here. So BD upon DC is equal to BA upon AP. Right? Now see here. Since AD is parallel to PC, this angle is equal to this angle. Why? Because they are corresponding angles. If two lines are parallel, these two angles are known as my corresponding angles, and they are equal also. Similarly, you want to see clearly here, I have made a line parallel, and these two angles are what? Corresponding angles. Clear? Now this angle is equal to this angle. Why? See, lines are parallel, and this is what? Alternate angles. This angle and this angle are known as alternate angles, and they are equal. So this angle is equal to this angle, and this angle is equal to this angle, but these two angles are equal with each other. Why? Because AD is my angle bisector. So we can say that this angle is equal to my this angle. So what we can write? We can write angle BAD is equal to angle BAD is equal to angle APC, right? And we can write the logic also, corresponding angles. Similarly, angle CAD is equal to what? Angle PCA, alternate angles. Right? And it is given that these two angles are equal, so we can conclude that these two angles are also equal. So angle PCA is equal to angle APC. Why? Because angle BAD is equal to angle CAD. angle bisector, so it is given. Clear? Now look at this triangle, triangle APC. If two angles are equal in a triangle, then the sides opposite to the angles are also equal. These are basically what? Isosceles triangle, right? Two angles are equal means isosceles triangle. So we can write that angle sides opposite to these angles, and this side is equal to this side. So AP is equal to AC. So we can write AP is equal to AC. Right? Now we can replace AP here. What we can write? BA upon AC. This is what we need to prove, that BD by DC is equal to BA by AC. Right? What we have done? We have drawn a line parallel to AD, and we have proved according to BPT this ratio first, and then by using the corresponding angle and alternate angle property, we have shown that this AP is equal to what? AC, and replace this AP by AC, hence our theorem is complete. Okay. Okay, we will learn another property or theorem, you can say, which is based on BPT, right? Now I am not writing the statement here. Theorem says that if there are three lines parallel to each other, I have drawn this L, M, N. Okay, this L is parallel to M and M is parallel to N, means all three lines are parallel to each other. And if we draw two transversal, one is L1, another is L2. These two lines are what? Transversal, cutting the parallel lines at point A, B, C, P, Q, R. Okay. So the theorem says that ratio AB upon BC is equal to PQ upon QR. Means what? This upon this is equal to this upon this. Let us see how it works. Okay, what we will do? We will just join this PC and name this point as D. Right? So my APC is a triangle. APC is a triangle, and BD is parallel to this one side AP. So we can apply BPT here. So by BPT we can write this upon this is equal to CD upon DP, or we can write the reciprocal also, that by BPT we can write, so say in triangle ACP, right, by BPT AB upon BC is equal to PD upon DC. You can write the reverse order also. AB upon BC is equal to PD upon DC. In PPT what we have proved, CB upon AB is equal to CD upon DP. So you can write the reverse or reciprocal also. Correct? PD upon DC, you can write BPT as a logic. Now in triangle PCR, same logic we can apply. Since DQ is parallel to CR, so we can say that PD upon DC is equal to what? PQ upon QR. Again, logic is what? BPT. From these two, both are equal to PD upon DC. So we can say this is equal to S, hence AB by BC is equal to PQ.